And now we are live sa ating Facebook group page, and we are going to discuss Archimedes Principle, the principle of buoyancy. Na kung anong mulutaw mo sa tubig, ganon. Okay, let's start. So, saan nga ba nag-start itong principle of buoyancy? Okay, so wait lang ha, inom sa tubig. So the Greek mathematician and physicist, we have Archimedes, okay? He discovered how to determine whether a crown is made up of pure gold by submerging it in water. Okay? Actually, naligo rin siya sa bathtub. Katong nga time, gisugo siya sa king, no? Kaya siya. Archimedes, kanang itry daw nig betest kung pure gold ba ning ako ang crown or dili. Moto, nakaana si Archimedes na, saan man ako ni, uy? Saan ka niya pag-solve na pure gold ba siya o dili? Katong naligo siya, naligo siya no, so start ka siya giliguan kay bathtub. Pero, pangit di ang bathtub sa una. Lahi lang bathtub karon bathtub sa una ha. But, social na lang bathtub na sa una. Naligo siya sa bathtub, then, while nagunit-gunit sa crown, nahulog bitaw ng crown, nahulog sa tubig ang crown. Og dito niya na-discover. Okay? Dito niya na-discover kaya nag-submerge bitaw ang ang crown, no? So that means the crown is not a pure gold daw, sabi niya. So sabi niya, Eureka, Eureka. Ibig sabihin, I found it. Tama ba to? Tama bang ang description sa Eureka? I have found it. Ano niya. Tapos, kung naked siya ha, na nasa bathtub, naligo, oo. Na, itry lang niya ang crown dito sa bathtub. Nga na siya ka-bright, di ba? Dito niya na-discover. Okay? So, pag human ato kay, wala siya ilis, no? The story is wala doon siya ilis, no? Wala siya ilis na doon siya sa king. Di ba? So anyways, actually naligo lang siya sa may palasyo naman po siya naligo dapat ato. So dool lang siya sa king na na area. Now, this principle governs the physics behind floating and sinking objects in fluids. But let's go back, no? Let's have a review first, a review about sinking and floating, no? If the density, di ba the formula of a specific gravity is the density of the object over the density of the water or the fluid. Again, the specific gravity formula, that was our first lesson, no? Yung last week pa. The density of an object over the density of the water or the density of a fluid. Now, if the specific gravity is less than 1, okay? Or what if the specific gravity is less than to the gravity of the fluid? That means the object will float pag less than siya. Again ha, if the specific gravity of the object is less than 1, that means the object will float at the water. Pag greater than 1, the object will sink. Okay? In this case, what if di lang water ang fluid? Okay? What if di lang water ang fluid? So, there are other things pa na fluid like mga toyo, mga suka, or basta anything na fluid. What if di lang kay kana? So, ito yung technique class if mag-float ba siya or mag-sink sa fluid. If the density of the object is less than to the density of the fluid, the density of that object will float to that fluid pag less than. But if the density of the object is greater than to the density of the fluid given, the object will sink. Okay? That's a basic concept lang. Please take note of that one. Next, in this lesson, you will learn about buoyancy and Archimedes Principle. Nganong mulutaw ta sa tubig? Nganong kaya nato mulutaw? Nganong kaya po nato mag-sink? So, the learning objectives in this lesson, at the end of the lesson, you will be able to define buoyancy, calculate the buoyant force on a submerged object, and apply Archimedes Principle. So when we say buoyancy, the pressure in a fluid increases with depth. 'Di ba? As you go down or as you go down under the water, the mas greater imong pressure na ma-experience, 'di ba? I've mentioned last time that the pressure at saka the height is inversely proportional. Kung pataas imong height, the pressure is less. Pag pababa imong height, the pressure is greater. Yan yung na-discuss ko last time. Kaya nga, pag naka sa himpapawid or sa atmosphere na part, less imong pressure. But if you're underwater, under the pressure, below sea level, you will experience a greater pressure. If we have an object submerged in fluid, the force acting on the bottom of an object is stronger than the downward force on the top due to the pressure difference. Na-try ninyo na class kalagong bola or sige na bola. Kalagong maligo mo tapos na kay bola nga ginahawakan, di ba? Ang bola, di ba, ginatry mo og alsa, di ba? Mulutaw mo because of the ball. Okay? Ginatry mo because of the ball. Because of the buoyancy, no? Okay, because of the buoyancy. Gipalutaw ni ang bola. So in that case, kung sakay mo ana, mo lutaw pod mo. Upward force is what we call the buoyant force. Okay? Mo nang force na nagapalit sa inyo ha. Again ha, example tayo kanang maligo mo then meron kayong bola, then ginahawakan ninyo ang bola, no? 'Di ba? Of course, mulutaw man jud ang bola, no? Because the ball is less dense compared to the water. The ball is less dense na pag mag-float jud siya. So if you are going to try to hold the ball, then sakyan ninyo, of course the ball will submerge. Mag-sink jud ang bola, no? But not totally sink below the jud sa yuta niya, but the ball will submerge, and then ang ginatry niya og help na mag-float mo kung sakyan ninyo. And the force, ang force na naga-push sa inyo ha, na mag-float mo is what we call the buoyant force. That is the upward force. The fluid pressure exerts a force on the object in all direction, but the resultant vector from the sum of all the forces from the pressure is upward. The buoyancy of an object is also affected by the density of the fluid because iba-iba kasi ang density ng fluid. So that means, pag iba-iba yung density ng fluid, iba-iba din yung buoyancy, no? Iba-iba yung buoyant force. Take note, iba ang density ng water at 4 degrees, iba rin yung density ng sea water. Mapansin niyo na class na nganong mas dali mo mag-float sa seawater compare sa swimming pool. I-try niyo na observe, di ba? Or kung i-try na niyo nag-observe sa una, kung nakapansin mo, nganong mas easy mag-float sa dagat compare sa pool. It's because seawater is denser compare to the yung compare sa water sa pool. Again ha, mas dali i-float, no, pag naaka sa denser na fluid. How much more pag naaka sa Dead Sea? When I research, no, the density of the the density of the Dead Sea, we have 1,240, and that is greater than 1,000. 1,000 is the density of the water at 4 degrees. And then 1,020 is the density of the sum of the salt water or the seawater. And based on my research, ang density sa Dead Sea 1,240. Grabe, no? Grabe ang salt content. Grabe ang salt content sa Dead Sea, no? Because it grabe kakuha yung density niya. So sir, if magpunta kami ng Dead Sea, sir, then mag-float kami doon, sir. Mas dali ba i-float dito ang sa Dead Sea? That's correct. Mas dali magpalutaw-lutaw kung sa Bisaya pa. Mas easy magpa-float doon sa Dead Sea compare sa ating the normal seawater. Kasi denser siya. Mas taas yung density. Now, if the density of a totally submerged object is less than that of a fluid, the buoyant force is greater than the weight of the object. That makes the object will accelerate upward. That makes the object will float. Kaya nga class, if you are going to try a ball, no, i-try mo mag-submerge ang ball, i-sink jud nimo. I-sink nimo ang bola. Nananasa sa underwater, no? Gi-hold lang nimo. But if you are going to let it go yung bola, let it go. Let go nimo yung bola under the water. 'Di ba? Pasaka ang ball. Tama? 'Di ba? Mo upward ang bola because of the buoyancy and also because of the density. The density of the ball is less than the density of the fluid. Maunang maglutaw siya. Okay? And that force, no, ang force na nag-exert sa bola to lift up para mag-float is what we call buoyant force, the buoyancy. Okay? Pero kita tao, no, kaya nato magpa-float-float, kaya po nato magpa-sink. Sige, ginabuhat ganyan. I forgot the may ginagawa tayo para mag-sink tayo, no? Yung mag-stay tayo under the water. I forgot the term na siya, kung mag-float naman, we can control, di ba? We can control our body na mag-float-float ta. But if we try to go underwater, like mag-stay doon, na siya term? I forgot. Magsisid, yes. But tama ang sinabi ni Manili no, magsisid, no? Kadang mga usa kita kanila mga magsisid na mga tao basta ganon. I don't know ano yung ginagawa nila para mag-go down sila, no. Naana sila something na ginabuhat para mag-sink jud sila. Naana sila something na ginabuhat para mag-sink. Kung mag-float ta, we tend to balance, no. We tend to balance our ginatay nato mag-float ta sa water, gina-balance nato ang atong lawas sa tubig para mag-float ta. Ang explanation ginapagamay nato ato ang density. Okay? Ginapagamay nato ato ang density sa atong lawas by sa hangin nga part, and also kalimot man ko sa term yung magsisid, I don't know ano yung ginagawa nila nganong mag-float sila. Siguro murag na sila ginabuhat, no, para yung density ng ating katawan is greater than sa density sa fluid. Nana sila ginabuhat? I don't know. Nakalimot ko sa term. Really, sabi ni Sai Carlos release salve bubbles either sa mouth or nose. Mo na ang mag-sink. Wala mo ko ka-try ba?
Wala mong ginabuhat, sir, pag maligo may ka na sa swimming pool or something.
Kung gusto mo mag-sink.
Oo, sir.
So wala mo'y hangin, no? Wala kayo mo'y hangin nga. Ay, grabe yung pag-release sa hangin or naga-bubbles lang mo. Saan na siya?
Kanang murag mo hinga mi pa siya murag mahinga mi sa under. Ay, dili mahinga pa ng murag i-exhale na mo.
Wait lang murag. Na ako ipangutana siguro no? Murag relation na siya sa biology, di ba? About sa paghinga o pag under the water, no? Mangutana sa ako about na concept, no? Nganong nagasing ang tao. But sige lang, I will try to contact some people, no, about that one para ma-relate ba na to sa buoyancy, no? Kay tao biya ta. Nganong mag-sink. Labo na tag ay sir, mag-sink na ka sir pag nalumos na ka. Ayun sir. Yeah, pag malumos mag-sink naman jud ka, no? Of course, pag malumos mag-sink man jud ka dira, no? But after ni mo malumos, mukalit go kag lutawan after. Mulutaw go ka na after. Kanang mga lang sa nang mga nalumos na tao, pila ka days maglutaw-lutaw na sila. Because of the I don't know the explanation of that one, no, but I think you can ask some sa lang sa tao. Maybe you can ask the expert about that case, no, yung relationship sa buoyancy sa ato ang body. Sa labo na sa water. Sige lang, I will try to communicate other people about that one. Curious kay ko about ana. Yeah, I'm so curious, no. I never experienced jud mag-stay at the bottom of the water, no, like sa swimming pool. Okay? Again, mahadlok lagi ko basig ni shark. Wala pa jud ka try, mahadlok ko. Pati po ni mga diver, mga scuba diver. Kana sila tong without using oxygen pa ha, yung mga divers na wala pa naga-oxygen. Okay, naay sabi daw ni Google. Naman ni Google, no. Si Sir Tapulan kayo mag-search sa Google. Sabi ni Kalonod, so when you exhale, okay. So when you exhale daw, you reduce the lower density stuff and tip the balance towards denser than water. So when lungs deflate, the body density changes and you sink. Okay. Okay. What an explanation, no? Sige. Ay mag-explore lang siguro ko after, no? About that one. Thank you so much, Kalunod. Yan, na-curious jud ko, ana. Na-curious jud ko, ana. Di ba? Pati ako, na-curious ko. Yeah, again, I never experienced that one pa to stay at the bottom of the water. Wala pa jud kay. Again, mahadlok lagi ko. Even on the swimming pool. Pero I know how to float, manggod. Kabalo ko mag-swim. Kabalo ko magpa-iro-iro mag-swim. Kabalo ko mag-float. Okay. Now, let's continue. The weight of a totally submerged object, denser than the fluid, is greater than the buoyant force, so the object will sink. Pag malaki yung density ng object mo, of course, magsisink talaga siya. Magsisink talaga siya. And, sorry. But, if ang weight ng object mo is konti lang, I mean, maliit lang siya, dili kay bugat, or the density of the object is lesser than the density of the fluid, mag-float siya. Okay? However, the object is in equilibrium if the buoyant force cancels out the weight. Archimedes Principle states that the upward buoyant force applied on an object completely or partially submerged in a fluid is equivalent to the weight of the fluid that the object has displaced. And we have this formula. Okay? B stands for buoyancy. Okay? B stands for buoyancy. So, sama ng PF. This small p is the density. F stands for the fluid. So the density of the fluid times the acceleration due to gravity times the volume. That's the formula of buoyancy. Again, the formula of buoyancy, we have density of the fluid times acceleration due to gravity times volume. So paano na siya na-derive? Class, the buoyant force is equal to weight. Again, the buoyant force is equal to the weight of an object. Okay? Sir, but sir, how come naging ganito yung formula? Now, let me explain. The density is equal to mass over volume. Tama? Density is mass over volume. If you are going to manipulate the formula of density, given that the mass is missing, mass is density times volume. Kaya nga, substitute the M here, dyan, naging ganito ang formula. The density of the fluid times the acceleration due to gravity times the volume. And the unit for buoyancy, buoyant force, of course, from the word itself, force. The unit for force is Newton. The unit for buoyant force is Newton. Okay, let me explain bakit naging force, bakit naging Newton. The density is kilogram over cubic meters. It times mo siya sa acceleration due to gravity, which is meter per second squared, that's the unit. It times mo siya sa volume, which is cubic meters. Makancel, ang naiwan is kilogram meter per second squared, and that explains bakit Newton ang unit ng buoyant force. Of course naman, from the word itself, force, the unit for force is Newton. And this is the equivalent. That's the derivation ng bakit Newton. Next. Okay? The formula. B is for buoyant force, which is in Newton. PF is the density of the fluid in kilogram per cubic meter. The G is the acceleration due to gravity. And we all know, we use 9.81 to that. V is the volume of the fluid displaced in cubic meters. We should always follow SI unit. We should always follow SI unit. Okay, next. Let's have also the totally submerged object, no? If an object is totally submerged, the volume of the fluid displaced is equal to the volume of the object. And the mass of the fluid displaced is equal to the mass of the fluid is equal to the density of the fluid times the volume. Maune itong ganina tong derivation ganina sa formula. So the buoyant force can be written also just like this. Again ha, the buoyant force can be written also just like this one, yung weight na formula. Again, the buoyant force is equal to the weight of an object. Okay? The MF stands for the mass of the fluid displaced, no? And alam niyo yung G is acceleration due to gravity. The buoyant force of an object immersed in a fluid is equal to the weight of the fluid displaced. Moto kanina, itong formula. And this is valid no matter the shape or composition of the object, and this is known as Archimedes Principle. Note, the buoyant force is positive since it always upward. Mo na hinungdan nga nung mag-float ta or mag-float ang isang bagay. Okay? Again, the buoyant force is positive since it is always upward. Now, how about floating object? Okay, please take note. Actually, naingon na ako ni ganina. Any object whose average density is less than the density of the fluid, it will float. Again, any object whose average density is less than to the given density of the fluid, it will float. Pag less than. Pag greater than, it will sink. Okay? It will sink. When an object is floating, only a portion of the object is submerged. So the volume of the fluid is displaced and it is equal to the volume of the object immersed, not of the volume of the entire object. No, napansin ninyo na class, no? Kanang again yung sa bola, how let's have the ball. Kaya mo na usually no pag maligo mo swimming pool or unsa ba? Dagat. Gidala ninyo ang bola sa dagat. Of course, pag ilabay ang bola, mapansin ninyo class na ang bola, mo ni ang water ha, water na part, na ay part sa bola nga na-submerge sa water. Napansin niyo na? Di ba na ay part sa bola na nag-submerge sa water? So far pa lang, no, so far, ang akong nakita nga mo ni ang dagat, tapos, wag ni patong lang gani siya, is ang balloon. Yeah, ang balloon. There are balloons, no, nga pag ibutang nimo siya sa dagat o sa tubig, mura siya mo patong lang, yan, mura siya ni patong lang jud siya. Na ay portion, no, na ay portion ng submerged. Na ay portion, but it is very difficult to observe, no, asa na part na portion, no, but of course mailan man nimo nga nag-submerge siya kay nabasa man. Okay? But if based on observation lang, no, mura siya nagapatong lang. Same with styrofoam, di ba? May mga styrofoam, no, pag ilabay mo sa dagat or sa tubig, mulutaw lang siya, mura siya ni patong lang yun. Unless imong gisakyan, mo submerge yun siya. Now, for an object float, it has to be in equilibrium. The buoyant force is equal to the weight of the object. And the weight of the fluid displaced is the same as the weight of the flowing object. And this is known as the principle of flotation. The volume of the displaced object, the volume of the fluid displaced over the volume of the object is the same as or is equal to the ratio between the density of an object and the density of the fluid. Again ha, the volume of the displaced or fluid displaced over the volume of an object is equal to the ratio between the density of an object and the density of the fluid. Equal sila. Sa mga nagtanaw sa live, naagod ko naay nakabutang sa kong live na anong tawag dyan? Subtitle. Pati Bisaya, try to observe sa ko agi tawo na ko akong live no, na ay na ay subtitle nga Bisaya. Makita jud siya. Amazing. Depende kung ang mga nagtanaw sa live kay ano. Pero karon kay nawala ang subtitle. Ang caption di ay naka-turn on pala yung caption ko kaya pala. Okay. Anyways, most submarines are made of very dense steels, no? That makes them most submarines will sink. Okay? Because the materials used to build submarines, no, yung mga steels, no, mga bakal, kay mga taas yung density. But due to the low density air inside, the average density, okay, from the submarine and air, it can be less than the water. Kaya nga, there's a possibility, di ba, makita niyo mga submarines kagaya nito, ang partially submerged, okay, napiuban na nasa taas, no? Napiuban kung i-control lang niya ang amount of air, no, inside the submarine, the ballast tank, change yung density ng submarine. Kaya nga, mapansin niyo na yung mga submarine nasa tubig, ilalom, tapos sa taas. Okay? And wala pa ko kitag submarine in real life. Sana wala kakitag submarine, no? I'm so ma-happy na ako pag makakita ko og submarine. Wala mo ko nga nasa samal ba? Asa niya makita ang submarine class? Of course, sa dagat, no? Naman dyan sa dagat ang submarine, no? But, asa nga dagat na submarine? Natin submarine sa Pilipinas. Natin submarine. Luya po na ito magira-gira, no? Anyways. Okay. Let's proceed to solving. Ay, natin sa DMMA. Submarine sa DMMA. Skulahan man to. Karang, the actual, karang makita din ako sa dagat. Okay ha? Wait lang, magkuha sa akong tubig ha. Then, let's solve this problem. By the way, there are 6 problems, no? There are 6 problems in this lesson. So, we are going to solve all of them. Minom sa akong tubig ha. Magkuha sa akong tubig sa gawas. Okay, I'm back. So let's solve this one. Let's solve this one. Frank, nasi Frank, no? Frank. Pero natulog si Frank.
Sir, saba kayo preso?
Mauna, naglag-laag, charot. Sige na lang, chat na lang na. Actually, nabuhat na ako ang interpretation na lang akong kulang sa inyo, ha? Yeah, the construction, yung mga words na itong kulang sa inyo, ha? Wala akong update. Pero, I will try my best to send it Thursday. Pero okay lang ba mag-meet Friday siguro or Saturday? Okay lang?
wala ko sa Saturday, sir, pero pwede sa Friday.
Friday, okay lang Friday.
Opo.
Ay, pero i-update lang ta ka kay basig magdavo ko sa Friday nang invite mo ko to sila og samgyup. Anyways,
Sige, sir. Pero, sir.
mag-chat lang ta. Anyway, sige, let's solve this one. We have here the volume of the statue or statue. So, ba na ba sa statwa, sa Bisaya, the volume, we have 0.0300 cubic meters. And the mass, no? The mass of that statue is 70 kilograms. And that is fully submerged, no, in water. But it's given here, the density of the water, the density of the fluid is 1,025 kilogram per cubic meters. So we are going to calculate the buoyant force on that statue. So let's write the given, no? The volume of the statue is 0.0300 cubic meter. Wait na, pangit pagkasulat. And then we have the mass. The mass is 70 kilogram. Actually, no, in this problem, wala pulos ang mass. In this problem, design ra ang mass diri. The density of the fluid is 1,025 kilogram per cubic meters. And the acceleration due to gravity, yeah, we should include the acceleration due to gravity, no? The acceleration due to gravity is 9.81 meter per second squared. Sige, now, the formula that we are going to use is this one. The buoyant force is equal to the density of the fluid times acceleration due to gravity times volume. Di ba wala nakabutang mass, di ba dire? Wala nakabutang na mass. So, di na to siya include. Okay? Di na to i-include ang mass dire. Design na rin 70 kg dire, no? Design na. So buoyancy is equal to the density of the fluid is 1,025 kilogram per cubic meters. And then the acceleration due to gravity is 9.81 meter per second squared. And then the volume is 0.0300 cubic meters. Paki-multiply daw ko without applying significant figure. What's the answer without applying significant figure? Okay, thank you so much, Crisel. It's 301.6575 Newton. Take note, ha? The unit is Newton. The unit for buoyant force is Newton. Force man, Newton. And thank you also, Crisel. Sabi ni Crisel, applying significant figure, the answer is 302 Newton. And this is now your answer. Okay, that's very easy pa, no? That's our answer, 302 Newton. So kindly copy before we will proceed to your next example. Kayo ang magsosolve sa next example. Again, ha? Kayo ang magsosolve sa next example. Okay, for our next example, this one, kindly solve. Again, kindly solve. Okay, let's solve this. Ay, God. Oh my God. Let's solve. Let's write the given. So we have here the given are the following. The volume of the statue pa rin na statue pa rin. The volume of the statue is 0.300 cubic meter. Ay, sorry. 0.0300. Yan. Cubic meters. Then, the density of the fluid is 900 kilogram per cubic meter. And then the acceleration due to gravity is 9.81. And the formula we have, buoyancy is equal to the density of the fluid times acceleration due to gravity times volume. So the density of the fluid is 900 times the acceleration due to gravity is 9.81 times the volume is 0.0300. What is the answer without applying significant figure? Yes, Alani. Alani, are you there? Alani? Alani, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Wala si Alani. Naasa si Alani. As a consequence, ibutang siya sa waiting room. Yes, Ibay. Ibay? Alyssa? Or Alisa Ibay? Press. Asa na si Ibay? 10, 9, 8, 7, 6, 5, 4, 3, 2, wala po si Ibay. So, sa waiting room. Next. Yes, Kalunod. Alessandra. Kalunod. 10, 9, 8, 7, 6. Yes, Kalunod. What is your answer, Kalunod, without applying significant figure? Pero hinay kaayo mo audio, Kalunod.
Ay, ako problem sa headset na po, sir. Pero
sige lang. Okay lang. Sige. What's your answer?
264.87 newtons po, sir, without applying significant figures po.
Okay, thank you so much. 264.87 Newton. Thank you so much. Now, the final answer, applying. Okay, that's correct. No, one significant figure lang. Again, one significant figure lang siya because of the density of the fluid given man siya na numerical. The answer is 300 Newton. That's the answer. Okay? So kindly copy before we will proceed to our next example. Ba't siya naging 300? Okay, take note how one significant based on the given. Diba? We should follow the least number of significant figures. So, isa lang man ang significant. So, kaya 1 yung significant figure natin for answer. Kaya 300. By the way, you should watch ma-amaze ko sa forecasting love and weather, no? Nagtatanong mo kay drama? Yeah. forecasting love and weather, diba? Kay Sungkang. And amazing kaayo, no? Na-amaze ko sa first episode pa lang daan. Grabe ilahang preparedness, no? Like, maana gud ko. Naay nga na sa Pilipinas. Nakaana jud ko na how grabe ilahang dissemination of information, no? Bisag gamay lang, bisag ulan lang gani ang abiso, sabi ana. Then mo to nag-advise og heavy rain, di ba? Ang mga tao kay naga-check na something sa Pilipinas kay, oh my god. Like nakana jud ko, dito na part na ana ko may pa sa Korea, no? Ay, Korea. Ambot na kung iato ba sa Korea, but ginahan ko sa ingato na sayang system nila. Like updated sila always. Ay, wala, sorry Alisa, nag-chat unta ka. Ang chemistry nila kay di man sila bagay ni Songkang, kay ang bagay man dyan ni Songkang no kay ako. Mora na akong matubag. Ay, R18 ay okay raman. Okay lang man tong scene. Uy, excited na ako sa episode 3. Oo. Katupong 24, 21 ba to kang namjuyok, no? Wala po ko episode 2. Tanaw ko to niya. Dami kong time. Anyways, sige, let's continue. Let's continue. We have here a problem, another situation. A 180 kilogram load is attached to a helium balloon. The question here is, we are going to calculate the minimum volume of helium needed to lift the load if the density of the air is 1.29 kilogram per cubic meter and the density of the helium is 0.179 kilogram per cubic meter. Now, let me show you this one muna ha. Of course, gamay jud ang density sa helium kaysa sa air. Kung saan paglupad sa balon. Sige daw be. O saan paglupad sa balon kung dako ang density sa helium compared sa air, hindi mo lupad. Kaya nga 'di ba, if you are going to blow a balloon, of course, di siya mulupad because yung hangin na ating ginamit is denser. Okay? Denser yung hangin natin ginamit compare sa density ng air. I mean, mas dako atong density na sa hangin, no, compare sa density sa air. Maong di siya mulupad. Pero yung helium, bakit merong mga balon na lumilipad? Because of the helium. The density of the helium is less than the density of the air. Kaya nga, siya, mulupad. In this situation, no, na 180 kilogram na butang or object, no, it's very heavy, 180. Then there is a helium balloon attached to that. The question is, we are going to determine the minimum volume of helium needed to lift the load if the density of the air is 1.29 and the density of the helium is 0.179. So we should also consider the density of the air. Sir, bakit kailangan natin malaman i-consider ang density ng hangin? Malamang, kimulupad gud ang balon, so na-adyo presence of hangin dira, no? So of course, iyaman ang, di ba? So, I mean, di ba sugaton something, but i-consider nato ang density sa hangin, sa air. Okay? Sir, paano ni siya i-solve? No, tuturuan ko kayo ng shortcut, okay? But later, I will explain the derivation, okay? I will explain the derivation, no? Paano siya na-derive ang formula, but let's proceed to the shortcut. Let's write the given first. The given are the following. The mass of the load, ml, the mass of the load, mass of the object, is 180 kilograms. And then, another given, we have the density of the air. The density of the air is 1.29 kilogram per cubic meters. And the density of the helium, of course, you know naman, di ba, the chemical symbol of helium, He, no? Okay? The chemical symbol for helium is He. So, the density of the helium is 0.179. Now, if we are going to go back to the formula of density, density is mass over volume. Tama? Density is mass over volume. Pag ang missing kay volume, it's mass over density. Tama, di ba? Pag missing ang volume, it's mass over density. So manipulate ko lang yung formula. In this case, volume. The minimum volume yung hahanapin natin. So ito yung mangyayari. Volume is equal to the mass of the load or mass of the object divided by the difference between the density of the air at saka the density of the helium. Okay? I-subtract nimo ang density sa air at saka helium. Mas mauna ang air. It's because pag mauna ang helium, ma-negative, di ba? Ma-negative siya. And also, wala may negative na volume. Okay? So, mauna ang formula. Mauna yung formula na itong gamiton to solve to the minimum volume. Later, I will explain the derivation of this formula. So, volume is equal to the mass of the load is 180 kilogram. The volume, the density of the air is 1.29. The density of the helium is 0.179. Now, what is the answer without applying significant figure? Yes, Maniri. What is the answer without applying significant figure? Maniri?
Ay, wait
Nasi
lang po,
man-
sir. Kaya ko ako pa yung ano ko.
Sige. At least itingog ka. Kulbaan ka. Sige, so kindly solve.
Ang naglabas po, sir, kay 162.0162016.
Okay, let's have this one, 162.2. Okay? Of course, what is the unit? The unit is cubic meters. Thank you so much, Maniri. Now, for your final answer, based on the given, the least number of significant figure is 3. The least number of significant figure is 3. So our final answer, the volume is 162 cubic meters. Okay? Of course naman, cubic meters because volume yung ginahanap. So that's the unit. Okay, cubic meters. Again ha, mauni ang formula na inyong gamiton pag ganito ang situation. Okay, pag ganito ang situation. Sir, what is the derivation of that formula, sir? What is the derivation of that formula? Sige, wait lang ha. So let me derive the formula, no? There are two things na kailangan nyo i-consider. The formula of buoyancy is mass time, in this case, mass of the helium, okay, times acceleration due to gravity plus mass of the load times acceleration due to gravity. And the buoyancy here is the same as the density of the air times acceleration due to gravity times volume is equal to itong mass of the helium times g times acceleration due to gravity. Ay, wag na something kulang. Tama. Kasi siya, it can be transformed into the density of the helium times acceleration due to gravity times volume. Saan galing? Take note, mass is density times volume. Again, mass is density times volume. Plus, this one, the mass of the load times acceleration due to gravity. Karon, makancel na ng G. Makancel na siya. Diretso na itong cancel. Ang naiwan, density of the air times volume is equal to density of the helium times, wala na G, sorry. Wala na G. Plus the mass of the load. Combined like terms, you have the density of the air times volume minus the density of the helium times volume is equal to mass of the load, the given object. Then, volume ang gipangita, di ba? Volume, so kailangan nimong i-factor out. Okay? Then, divide both sides, no? Divide both sides by the density of the air minus the density of the helium. Kaya nga yung formula naging volume is equal to mass of the load or the object divided by the density of the air minus the density of the helium. Okay, that's the derivation of the formula. Okay? Then kindly take a picture, and then after that one, I will give you your next example. Okay? Magna-next example na tayo. The next example is similar lang, yeah, quite similar. Okay? I will suggest same formula lang yung gamitin ninyo, kanina formula. But you need to understand the problem. Kaya nasa yung murag gamay twist. Na gamay twist ang problem. I want you to answer this one. Yes. The mass of an empty deflated balloon is 2 kilograms and a 180 grams load is attached to that balloon. Calculate the minimum volume of helium needed to lift the load at the peak of Mount Everest if the density of the air is 0.547 kilogram per cubic meters and that of the helium is 0.179 kilogram per cubic meters. So I want you to answer this one. You can use the formula, no, yung ginamit natin kanina para mas easy. Sige, time starts now. Okay, let's solve. Okay? Isa pa ang nakakuha tamang answer, no? Isa pa lang. Sige, let's solve. So the formula, let's write the given. Let's write the given. The mass of the load is 180. Sir, i-consider ba namo ang mass sa balloon? That's correct. Kailangan ninyo i-consider ang mass sa balloon. The mass of the balloon is 2 kilograms. Ay kailangan di, sir, malamang kay gi-attach man siya. Di ba? Ang balloon gi-attach sa mali. Ang load gi-attach sa balloon. Then the mass of the balloon is 2 kilogram. Okay? Then the density of the air is 0.547. So gamay na ang density sa hangin, no, pag naka sa Mount Everest. Then the density of the helium, we have 0.179 kilogram per cubic meters. So the formula we have, volume is equal to the mass of the load plus the mass of the balloon. Kailangan mo i-add ang duha ka mass. The net mass. The net mass. Then divided by the density of the air minus the density of the helium. So 180 plus 2 divided by the difference between 0.547 and 0.179. So, the answer, without applying significant figure, the answer is what? Yes. Yes. Yes, Omar? What's the answer? Without applying significant figure pa. Walang significant figure. Omar?
494.
Omar?
No, sir.
Okay. What's your answer?
494.56.
Point?
0.56.
Okay, 56. Thank you. What's the unit? The unit is what? Putol-putol lagi si Omar. Sige. What's the unit, Omar?
Cubic meters po.
Okay, ganda. Sige, thank you. So the answer of Omar is correct. 494.56 cubic meter. And applying significant figure, the volume becomes 495 cubic meters. That's the answer. Okay? Ito yung sagot natin. So kindly copy before we will proceed to the second to the last example. Again, mag-second to the last example na tayo. Utanas na utanan no nganong i-add nato siya by 2. Dili lang siya limited sa kalunod no. Dili siya limited sa mass sa load. Na naka-indicate kasi yung mass ng balloon. So of course, 'di ba kung mulupad, of course, i-consider po nato ang mass sa balloon. On our previous example manggod, wala naka-indicate ang mass sa balloon. Wala i-specify dito ang mass sa balloon no. Ang load lang. But this time, meron na kasing meron naka-indicate na kasi yung mass ng balloon, naka-deflate na yung balloon, no? So we should consider the mass of the balloon. Okay? Pero kung given ang mass sa balloon, i-appeal. Pero pag dili given ang mass ng balloon, wala man siya dili man siya madungag kay wala man gibutang ang mass. So di siya ma-appeal. For our second to the last example, now, like Archimedes, you are tasked to verify if a 14.7 kilogram crown is made of gold. A weighing scale reads 13.4 kilogram when the crown is fully submerged in water. You know that the specific gravity of gold is 19.3. The question, calculate the specific gravity of the crown to determine if it is made of gold. Actually, class, na-derive na ako ang formula, ani. Again, na-derive na ako ang formula. Later i-show na ako ang derivation, no? But let's proceed to the formula I derived, no? Wait lang, ha? So, natin ginatawag na apparent mass o actual mass, no? Again, meron tayong tinatawag na apparent mass o actual mass. In this case, we are going to write the given. The actual mass is, yung given mass rather is 14.7 kilogram. Then the apparent mass is 13.4. Again, 13.4 kilogram. That's the apparent mass. Then the specific gravity of the gold is 19.3. Sa gold sa gold, AU. AU means gold. That's aurum. Okay? The specific gravity of the gold is 19.3. So we are going to get the specific gravity of the crown. Again, we are going to get the specific gravity of the crown. So what's the formula? Sg is equal to mass over mass minus the apparent mass. But that's the formula. Okay? Mo na ang na-derive na formula, no? Later, i-derive na ako. So Sg is equal to mass over mass minus apparent mass. 14.7, of course, walang negative na specific gravity. Again, walang negative na specific gravity. 14.7 over 14.7 minus 13.4. What's the answer? Pila SG class, i-divide daw. Pag i-divide ko, yes, Perez, Mark, Vincent. Mark, Vincent, Perez, are you there? Mark? Mark?
Yes, sir.
Okay. Paki-divide daw ko, Mark. 14.7 divided by 14.7 minus 13.4. Kaning nasa given. What's the answer, Mark? Without apply, diretsoan na lang with significant figure na, with significant figure.
11.3, sir.
Okay, thank you, Mark. The answer is 11.3. In this case, dili siya 19.3. Okay? The specific gravity, lahi ang nasa kong utok no basta SG. Sorry. Aga na, ang nasa kong utok no basta SG kay kuan, salary grade. Okay? So the specific gravity of the crown is 11.3. That means the crown is not made of pure gold. Again, the crown is not made of pure gold because the specific gravity of gold is 19.3. Unya 11.3 naman ang specific gravity sa crown. Okay? Pero tama nag-ingon sa ako ana, sir, naalan siya sir, dili siya Yeah, tama ito yung mong gingon, sir, na not pure gold, pero nasa gold content. Kasi katawag, ana? Kalimot ko sa term. Kaya, di ba na, sa uban karon di ba, na ginatawag na karat-karat, di ba? Pila ka karat, yung gold, ganon. Okay? Dili siya, nasa gold content, gamay lang, but dili siya pure gold. So in this case, no, the crown is made out, the crown contains gold, but the crown is not made of pure gold. Again, ha? There is a content of gold sa crown, no? But the crown is not made of pure gold, rather. Not made of pure gold. So, nga na lang ang process. Sir, yun sa pag-derive ang formula. That's the question, no? Doon sa pag-derive ang formula. So, i-derive na to. Medyo taas-taas ni siya, no? We have the weight, the formula of weight. No, this is the derivation, ha? This is the derivation. The weight is mass times acceleration due to gravity. Tama, diba? The weight is mass times acceleration due to gravity. We all know that mass is equal to density times volume. Again, mass is equal to density times volume. Ron, i-substitute natin maging density of the crown. Yan, kasi crown man ito, di ba? Crown. Density of the crown times acceleration due to gravity times volume. The buoyancy, the difference between the actual weight at saka the apparent weight. Again, the buoyancy is the difference between actual weight at the sorry. The buoyancy is the difference between your actual weight at saka apparent weight. Okay, ito siya. In this case, your buoyancy becomes density of the crown times acceleration to gravity times volume is equal to weight minus the apparent weight. Then taking the ratio between the next step. Ratio. The ratio between the weight at saka the difference between the actual weight at saka the apparent weight is equal to density of the crown times acceleration due to gravity times volume over the density of the fluid times acceleration due to gravity times volume. Then makancel ni siya, ang maiwan is W over weight minus the apparent weight is equal to the density of the crown over the density of the fluid. Yan. Pagkatapos, this is the formula of specific gravity. Again, di ba, specific gravity is the density of the object over the density of the fluid. Again, specific gravity is the density, specific gravity is the ratio between the density of the fluid. Malitad. The density is the ratio between the density nalibog ang ko. Wait lang, ha. Specific gravity is the ratio between the density of an object and the density of the fluid. So we have here SG is equal to mahimo na siyang SG kani. So weight over weight minus the apparent weight. Then we all know that weight is mass times acceleration due to gravity. So this one minus the apparent mass, then the gravity. Cancel ang G, cancel ni siya. Maging ganito siya, oh. mg, di ba? G, tapos m minus apparent mass. So, makancel. ang naiwan, specific gravity is equal to mass over mass minus apparent mass. And that's the derivation of the formula. Again, that's the derivation of formula. So medyo taas-taas din siya, no? Taas-taas din siya ng formula. So I will suggest, no, i-follow na lang yung formula. If ever maka-encounter kayo ng similar problem. Again, if ever maka-encounter kayo ng similar problem, just use this formula. For our last example, medyo iba, no? Iba ang last example, but the concept is still there. Okay? The concept is similar lang man din, pero nasa twist. Dili specific gravity ang gipangita. For our last example. Okay, last example na tayo. By the way, can you take a picture of this one, no? The derivation of our formula. Next, last example na tayo. So, for our example kanina, the specific gravity of the crown is 11.3. The specific gravity of gold is 19.3. So, the crown is not made of pure gold. Ito, your task to verify a 14.7 kilogram crown is made of gold. A weighing scale reads 14.1 kilogram when the crown is fully submerged in water. Given that this is the density of the water, the density of the fluid, again, this is the density of the fluid, no? You know that the specific gravity of the gold is 19.3. The question here is, calculate the density of the crown to determine if it is made of gold. So kung pareha sila og density, that means the crown is made of gold. I want you to answer this one, and this will be our last example. Kindly analyze, ha? Density ang gipangita. Density ang gipangita, tapos you are going to determine whether it is made of pure gold. Okay? Time starts now. Okay, let's solve our last example, no? Mhm. Although na mong answer for hand, but the answer on that answer ng for hand kay naka specific gravity na. Sige, let's solve, no? Let's proceed to my virtual whiteboard kay dili maigo ang space. Let's write the given. The mass is 14.7. Then the apparent mass is when submerging in the water is 14.1. So the formula of specific gravity of the crown, the formula is mass over mass minus apparent mass. SG of the crown, we have 14.7 over 14.7 minus 14.1. The specific gravity of the crown, tama yung sagot ni Ferhan, no, which is 24.5. The specific gravity of crown is 24.5. The question is density man, density. Take note, the formula of density is specific gravity. To get the density of this one, we have specific gravity is equal to the density of the crown over the density of the fluid. Yan. Again, the density of the crown times the density of the the density of the fluid. In this case, since we are going to get the density of the crown, specific gravity times the density of the fluid. Then the density of the fluid is 1,000. The specific gravity is 24.5. So times 1,000 kilogram per cubic meters. That means the density of the crown is 24,500. Okay, this is the density of the crown. Then the density of the gold, no, the density of the gold is 19,300. Again, the density of the gold is 19,300. So if you are going to compare, if you are going to compare the density of the gold to the density of the crown, mas malaki yung density ng crown. That means the crown will sink. Okay? The crown will sink. And also, base pa lang good sa SG, no? Sa SG sa crown, 24.5. Ang sa gold, 19.3. So the crown will sink and it is not made of pure gold. Again, the crown is not made of pure gold. Same pa rin, the crown has a gold contents, no? May mga gold contents ang crown, but as a whole, the crown is not made of the crown is not made of pure gold. Question before we will end. Okay, question. Walay question. Okay, now, for next meeting, this coming Monday, mag-quiz ta. This coming Monday quiz, the topics are the following. Ito, Archimedes Principle, Pascal's Principle, at saka yung pressure, fluid density, and depth na part na klase, which is last meeting, no? So, 3 topics na yung coverage ng ating quiz next meeting. Mga 40 items siguro yon. Again, mga 40 or siguro 30 to 40 items siguro yung quiz. Next week, Wednesday, magbigay ako ng instruction for your last PT. Again, for your next PT, next week, Wednesday, ibigay ko yung instruction. The deadline of your PT will be this coming March pa. March ang deadline sa PT. So, before we will end, I am requesting muna everyone to turn on your camera for documentation purposes. Again, yes, Saniel, you're raising your hand, Saniel.
Napindot siya, sorry.
Okay ra, sige. I am requesting everyone to turn on your camera for documentation purposes. Duha lang sila nag-camera, no? Talo na, opat. Okay ra, mga walay ligo. Daghan naman tao ako ligo. late biya ako no. Oy, maligo ko after. Oo. Huwag kayo dyan. Maligo ko after. Sige, so at the count of 3, 1, 2, 3. Smile. Okay. Class, na-observe na ako, no? Dagan na kay topics na discuss, but they're related, no? Related but Hey, Frank. Sige lang, Frank. Sige. Wala din silang balay ba? Asa kayo siya nilakaw? Ano sa balay? Ay, natin sa balay. Sabi ng picture na di ay na. Nakulbaan. Okay.
It's a prank, sir.
Ay, daghan na kay tag topics, no? Kanang napagod tayo next topic, the gas laws. Yes, include na ko sa exam tanan. Then actually no maglisod ko hatag og review nga naman. Akong schedule kay busy kaayo na ako klase college sa gabi. Plus akong part-time. Napud yung klase sa akong part-time. So I will try my best no to create a schedule for the review before exam. No, I do hope di pun mag-brown out. Okay? I do hope di siya mag-brown out. Then yan, na-observe jud na ako daghan na kitag topics as in. Mo na ko bombarded na mga but maumagod ang naa sa melts ba? So sige lang no. Basta laban lang. Ubay po ng topics no from power to work. Dapat pagkatag work energy theorem plus power plus density plus pili na ka-topics, no? So before we will end, let me call yes, Christian. Kabalo ko natulog si Christian. I mean napasa bed si Christian, no? Christian, can you lead us into prayer? Christian? Natulog di balik ba? Christian.
Yes, sir.
Okay, can you lead us into prayer? Mata na daw, yung mama ni mo.
In the name of the Father, the Son, and the Holy Spirit, amen. Lord, thank you for this wonderful day that you given to us. Thank you for this productive class. Amen.
Amen. Okay, thank you so much, Christian, for the prayer. So once again, thank you so much, S9, for participating sa ating synchronous discussion this morning. Have a nice day, everyone, and see you this coming February 28. And God bless sa inyo ang assessment at saka activity next week. Goodbye, everyone.